Hi guys, we're going to do system of equations. We're going to continue with the graphing mode, and I'm calling this day 2 because on Monday for day 1, we focused on all equations that were in slope-intercept form, which is y equals mx plus b. But today we're going to see a little bit of variation with our equations. Some will be in slope-intercept form, and then others could be in standard form that we have to move first into slope-intercept form. So again, today our same objective. We are going to determine the solution to 2 equations by graphing. So let's just recap right now how to determine a solution. First, you want to make sure both equations are in y equals mx plus b format. So I'm going to focus a lot on that one today just because, we are going to see different types of equations. Okay, so that one's going to be really the one I'm going to focus on. Once they are in slope-intercept form, then we're going to graph the 2 equations on the coordinate plane. And then finally, we determine where the 2 lines intersect, because that, of course, again, tells us where our solution is. Okay, if they intersect at one point, then your solution is one solution, and you identify it using an ordered pair. Okay, so let's recap our 3 types of solutions, okay? Our first solution is one solution, okay? And for one solution, that means that there's only one point of intersection that these 2 lines will ever meet at, okay? And then this is the one that we use an ordered pair to represent the solution. Our second type of solution that we could see, and we did see on Monday, is no solution. And we see no solution when the 2 lines are parallel because they are never, ever, ever going to cross. They're never going to intersect. So there's no solution. There's not one ordered pair that these 2 equations share together. And if you recall from Monday as well, I talked to you a little bit about how you can observe the equation to look when they are parallel. When the lines are parallel and there's no solution, you're going to find that the 2 lines have the same slope, but different y-intercepts. Okay, so that's something to really keep in mind when you see the equations. Okay, for example, if I had, let's say, y equals 2x plus 4 and y equals 2x minus 5, if you notice, they're going to both start. One's going to start up here at 4. The other one's going to start down here at -5. And again, they're going to have the same slope. So they're going to end up being parallel. Okay, so if they have the same slope, but different y-intercepts, then they're going to be parallel. Our third type of solution that we can see is infinitely many solutions, which you're going to come into contact with today. Okay, that means honestly, it's the same exact line. So honestly, you're going to have the same exact equation. So I always say here, you're going to have same slope, same y-intercept. Okay. So those are the 3 types of solutions. So let's get going with example number 1. Now, what I want to see is that you first look at your equations, and I want you to be able to look, sorry, like my graph was a little far down. I don't know why. Okay, so first let's look at our 2 equations. Okay, we have our first equation, 5x plus y equals 4. And then our second equation is y equals 3x minus 4. So if you notice this second one, this one's good to go already because it's in slope-intercept form. However, the first one, let's bring it down here and let's rewrite it. So if you recall, hopefully yesterday's lesson helped you understand how to go into slope-intercept form. So I want my y by itself. Just try to change colors. So I want my y by itself. So I need to move this 5x out of the way. So since it's a positive 5x, I'm going to subtract 5x to both sides. Now, since I want it in slope-intercept form, I want my x term to be first. I'm going to put negative 5x. Remember, whatever sign's in front of the number stays with the number. So since there's that minus 5x, that means it's a negative 5x. If you look at my 4 here, it's positive. There's no sign in front of it. So there I'm going to put y equals negative 5x plus 4. Okay, so I'm going to graph this one first since I'm using red, so I'll do that one in red. I'm going to start up at my y-intercept, which is 4. My slope is negative 5, which is negative 5 over 1, because we always need to move along the x and the y. So I'm at 4, but negative 5. So anytime it's negative, I always want to fall and then run to the right. So I'm going to go down 1, 2, 3, 4, 5, then right 1. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4. I can't go any further there. So I'm going to reverse. And now I'm going to go up 5. 1, 2, 3, 4, 5, and then left 1. And this is my line. If you remember Monday, my lines definitely don't come out too great with my stylus. That's okay. Okay, now again, make sure your equation represents your line. I had a negative slope, so my line should be starting up high and going down low. Okay, now I'm going to go back to my purple, and now I'm going to focus on graphing the second equation now. Okay, the second equation, negative 4, is my y-intercept, and my slope is 3 over 1. Okay, it's positive, so I am going to go up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. I can't go any further up, so I'm going to reverse. Now I'm going to go down 3, left 1, down 3, left 1. And here comes my line, my squiggly line. Now, while you are graphing, as long as you are graphing correctly, you should observe a point of intersection if there's one solution. And if you notice, it was right here. So again, anytime they intersect, that's one solution, and they intersected at 1, negative 1. Okay, next. Example 2. All right. Example 2, I'm going to look at my first equation. Y equals 5x minus 2. That's good. It's in y equals mx plus b. So I'm going to start with graphing that. My negative 2 is my y-intercept. So I'm going to go down to negative 2 on the y-axis. Remember, you always start on the y-axis. My slope is 5 over 1. It's positive. So I am going to go up 5, right 1, up 5, right 1. Reverse. Okay, so now I'm going to go down 5, left 1. And here is my line. Okay, now I'm going to switch over to another color. Go red again. Now, this equation, the second one, it is not in slope-intercept form. So I'm going to rewrite it down here. My goal is to get the y by itself. I always move my x term first if it's on the same side as the y. So since this is negative 10x, I'm going to add 10x to both sides. Cancel this out. I bring down my 2y. My x term comes first, so I'm going to go 10x. This is negative 4. I'm going to do minus 4. Now again, in order to get the y by itself, I need to divide by 2 to every single term. Now this leaves me y equals, now 10 over 2, it's a division, so 10 divided by 2 is 5x, and then negative 4 divided by 2 is negative 2. Okay. Now, I don't know about you, but all I hear is ding, 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 ding. What do you observe about the two equations? Well, hopefully you're sitting home and saying they are exactly the same. Okay, so obviously when I go to graph, I'm going to be at negative 2. Then I'm going to go up 5, right 1, up 5, right 1, down 5, left 1. And I'm going to draw my line. Wow, actually stayed like pretty perfectly on the other one. Okay, they are exactly the same line. So what that means is that it has infinitely many solutions. There's so many, they share every point, they share the same. So this is something that you do have to write. Infinitely many solutions. Okay. So again, same slope, same y-intercept, infinitely many solutions. Okay, let's do example 3. Example 3, ooh, they're both in standard form. So we got some work cut out for us. Okay, so what I'm going to actually do right now is I'm actually just going to write them into 2 columns just to kind of get everything nice and organized. Organization is the key to success. Okay, start with purple first. So I need this y by itself. I'm going to subtract 3x. Remember, move the x term first. Now I'm left with 3y equals, your x term comes first, so it's negative 3x plus 15, because the 15 has no sign in front of it, so it's positive. Now I divide the 3 to every single term. That leaves me with 1y. Negative 3 divided by 3 is negative 1x, or you can write negative x. And then 15 divided by 3 is 5. Okay, so what I'm going to do is I'm going to graph this one right away, just so then this way I'll jump over to the red color for my second equation. So I'm going to start up at 5. Okay, y-intercept's always your starting point. Now my slope is negative 1, which is negative 1 over 1. So negative, so not up, we go down 1, right 1. Down 1, right 1, 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 down 1, right 1. Reverse, reverse. So I'm going to go up and to the left, up and to the left, up 1, left 1, up 1, left 1, up 1, left 1. And there, again, it's a negative slope, so your line should always be starting up high and going down low. Okay. Now let's look at the second equation. We have 3x minus 6y equals negative 12. My goal again is to get the y by itself. You move the x term first. Now be careful here, because this is a negative 6y. negative 3x minus 12. So both terms are negative, negative 3x minus 12. Now I'm going to divide by negative 6 to every single term. So definitely be careful with this one. There's a lot of negatives. Okay, negative 3 divided by negative 6. Now, for anyone who is saying 2x, very common mistake. Negative 3 over 6 simplifies to 1/2. Okay, 6 divided by 3 is 2, but 3 over 6 is 1/2. And then negative 12 divided by negative 6, double negatives, going to give you a positive 2. So I'm going to start at 2. My slope is 1/2. So it's positive. So I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Even though I know I hit my intersection already, I do like you to fill out the whole graph. So I'm going to go now down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Now I'm going to draw my line. And here is my intersection, which is 2, 3. Again, if they intersect at one point, that means there's one solution, and you identify your solution by writing the ordered pair. Okay, example 4. Okay, the first one, x equals negative 4. Okay, so I wasn't here with you guys for this, but anytime it's x equals, then it's going to be an undefined slope, which is the worst curse word in math. So I'm going to go on my x-axis over to negative 4. And I'm going to just go up and down. Undefined. I wonder if you guys did slope do when I wasn't here. I hope so. I know Miss Kirschbaum loves slope dude, so if it was up to her, I'm sure you guys definitely saw it. Okay, the second equation. We have to change this into slope-intercept form. Okay. I am going to add the 3x. It cancels out, leaving me 4y equals 3x minus 4. I'm going to divide the 4 to every single term. Now I'm left with y equals 3 over 4 I cannot do anything with. Negative 4 divided by 4 is negative 1. I'm going to start with the negative 1. My slope is 3 over 4, so I'm going to go up 3, right 4, up 3, right 4. Now I'm going to reverse. Okay, and I definitely have to reverse in this situation because I have not hit a point of intersection yet. Down 1. I'm sorry, down 3. Left 4. Down 3. Left 4. There's my line. And if you notice, right here is my point of intersection. It's negative 4, negative 4. Okay, and finally, example number 5, which is the last one for today. The first one is already in slope-intercept form, so I'm going to go ahead and graph that first. I'm going to start up at 6. I'm going to go up 3 over 2, down 3, left 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 2. That's my whole line for the first one. My second equation, I have to put it into slope-intercept form. I am going to first subtract 6x. Don't forget, that's a negative 4y. This is a negative 6x plus 8. Now I'm going to divide by negative 4 to every single term. Just be careful here a little bit. This does simplify down. First off, negative divided by negative will give you a positive, so I'm not going to have any negatives there. And 6 divided by 4, you could divide 2 into both of them, and you're going to get 3 over 2x. And then 8 divided by negative 4 is going to give you negative 2. So I'm going to start at negative 2 for my y-intercept. My slope is 3 over 2. I'm going to go up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. Reverse, down 3, left 2, down 3, left 2. Oh boy. These two lines are parallel. So when they are parallel, then we have no solution. Sorry, that's a little messy with my stylus pen. Okay, these two lines will never ever touch. And if you, I've been keeping tabs on what I've talked about with the types of solutions. When it's no solution, I mentioned earlier, and I mentioned on Monday, that they're going to have the same slope, but different y-intercepts. Okay, so if it's no solution, it's going to be same slope, but different y-intercepts. Okay, so now what? Now we've completed the lesson. Okay, I gave you 5 examples to work with and look over. Okay, hopefully you followed along and either printed the PDF that I posted in order to follow along, or at least took notes or tried graphing, on your own using your notebook. So now you're going to complete the Google Slides, where you will do 3 practice problems, and then you'll complete your daily check-in for today. Okay, so good luck. Again, the Google Slides is a great way to check in with us. If you need any help, just let me know, and I can jump right onto your slides and really help you virtually. Okay, so let me know if you need any help. Good luck, and you're doing great this week. Bye, guys.